Eureka! The story so far. Things like to keep on doing what they're already doing. They don't like to start moving or stop moving. They are lazy. Another word for laziness is inertia. And now, mass. A large thing is equally difficult to move and to stop moving. Whereas a small thing is easier to move and easier to stop moving. The big rock has more inertia than the little rock. It is lazier than the little rock. Are all big things lazier than little things? Does inertia always increase with size? Oh, really? Well, why don't you take a huge cube of styrofoam and try to throw it? And catch it.
Hey. Huh?
Then do the same with a small cube of lead. Do you still think big things are lazier than little things? The small cube of lead was more difficult to stop moving than the big cube of styrofoam. In this case, the small thing was lazier. It had more inertia than the big thing. So inertia doesn't always equal size, or volume, or bigness. In fact, when we talk about how much inertia a thing has, it isn't really a question of how big it is, but of how massive it is. A massive rock, for instance, is a rock that contains masses and masses of stuff or matter. It's not merely big, but also solid and chunky, like a massive bulldozer or a massive ball player. You don't push things like that around very easily, any more than you can stop them easily when they come charging at you. They are too massive. Because of this, scientists took the word mass as a measure of inertia. The more the mass, the more the inertia. In spite of the fact that the styrofoam cube looks much bigger and more important than the little lead cube, it doesn't contain as much stuff. There's much less to it than there is to the lead cube. It has a far smaller mass. But just how much is a lot and a little when you're talking about mass? To find that out, we have to go to a place called Sèvres, near Paris in France, where a particular piece of platinum has been very carefully preserved. Scientists all over the world have agreed to call this little chunk of metal 1 kilogram, which is very convenient, because if you take a balance and put this piece of platinum on one pan and put any object you like on the other, a pebble, let's say, then if they balance exactly, you know that the pebble has a mass of exactly 1 kilogram. But what about the cube of lead? That feels as if it has a lot more mass than the 1 kilogram pebble. Well, all we do is put the cube in one pan of the balance, have a whole lot of copies of the platinum kilogram made up, pile these standard kilograms in the other pan until they balance the lead cube, and then count how many there are. 1, 2, 3, 4, 5, 6, 7, 18, 19, 20. There! Now we know that the lead cube has a mass of exactly 20 kilograms. Of course, we can do the same with the big important-looking cube of styrofoam. 1, 2... Sorry, you have only 2 kilograms of mass. So the lead cube has 10 times more mass than the styrofoam cube. Which explains why it's 10 times more difficult to push around.
Bye.